We have completed 3 of the 5 degrees of freedom: the main boom at the base of the arm, the telescoping mechanism, and the worm gear driven end effector. As shown in the videos, the linear actuators work well, but through the manufacturing process, we've identified a number of areas for improvement. For the main boom, we simplified the design of the channel to reduce the contact area between the parts and added a lubricated thrust bearing to ensure smooth operation. When assembling the telescoping section, we noticed that there was more play between the inside and outside of the slide than we think will be acceptable for a consistent operation. So we plan to add brackets on the bottom of the outside slides. This will ensure that the slides are tightly constrained and provide additional support for motion of the inside slide. Finally, we would like to replace the current shovel-like grips on the end effector with some more rounded designs. We plan to switch from bent sheet metal to 3D printed hard plastic, as this will allow us greater flexibility in grip geometry and features. We believe that it will take another 3 weeks to complete the other 2 degrees of freedom and the additional improvements for the arm, and we expect it to be fully functional in 1 week after part completion.
As you can see, we have one swerve drive module that's already been completed. Instead of machining all the modules at once, we decided to machine only one to make sure that everything works together. Through the process of machining, we redesigned a few parts to be optimized for both machining and use.
As you can see on the screen, our communications program is up and running. On the right hand side is my laptop, which runs the client side of things, sending data to the Raspberry Pi server. We did it this way since it is much easier to open a port and wait for a connection with the Raspberry Pi than it would be to try and sync connecting and drop with the command computer. Additionally, if we ever lose connection, it could be programmed to reopen the ports in a way to reconnect. In the video, we used a cell phone's wireless hotspot function to mimic the type of environment that we would be sending over during the competition. The problem we encountered with this method is that some service providers block incoming outgoing sockets, so to avoid this, we will either make sure that whatever we choose to use allows port forwarding, or use a VPN to get around this port forwarding issue.
UC Berkeley Cal Rover is excited to be a part of the 2016 Robo-Ops competition, and we look forward to showing you our final product in May.